Hello guys, again welcome to my YT channel. This is I am a singer, eternal voice. So we had done uh, presenting to you guys different problem solvings regarding physics problems. Okay, a lot, right? So now we will proceed to another topic, which is the thermodynamics. This is all about involving heat, right? Heat energy and then thermal energy, and then accompanied by the change from higher temperature to lower temperature. Okay, from hot substances to cold substances, usually the transfers like that, from a high temperature to lower temperature. There's a temperature gradient like that because we need to consider the formula Q is equals to mCp dt. Heat is equals to mass times specific heat capacity times the change in temperature. Right? So that's thermodynamics. So before going further, we need to understand the K terms for thermodynamics. Okay, then we have to understand the laws also. If the physics have laws, the the three laws of motion, we have also the three laws of thermodynamics. Okay, so the first law of thermodynamics is just like the law of conservation of matter. So we will just change the term. If the law of conservation of matter states that matter can neither be created nor can be destroyed by ordinary physical and chemical means, okay, then the first law of thermodynamics also state that energy can neither be created nor destroyed, but it can only be transformed to various types of energy. Example, potential energy, kinetic energy, heat energy, and the rest of the energies. So that's the first law of thermodynamics. Okay? So our second law, this law of thermodynamics is very important, okay? Because it talks about the entropy, the randomness and the disorderness of the systems, okay, in the surrounding. Meaning to say, the sum of the entropy in the system of the surroundings is always increasing, okay, day by day, something like that, okay. So it's gonna be the rule of thumb in the second law of thermodynamics. Remember, the sum of all entropies in the system of the surroundings is always increasing, or the entropies of the system in the universe is always increasing. Okay, that's second law of thermodynamics. Okay, and then how about the third law of thermodynamics? It talks about that perfectly crystalline solid at absolute zero, the entropy is equal to zero. Okay, perfectly meaning pure crystalline solid. Okay, that's absolute temperature. What's absolute pressure? Okay, something like that at STP, right? Zero atmosphere is absolute pressure, right? I'm correct? At STP, standard temperature and pressure at a pressure of zero atmosphere, ganon siya, di ba? No, not zero atmosphere, 1 atmosphere, sorry, at 0 degrees Celsius. That's absolute uh, zero, right? So it's not really the pressure, the temperature, sorry, because there's no such pressure zero. Okay? So yung ano ko, yung stock knowledge ko nakakaloka. Okay? Absolute zero is at temperature 0 degrees Celsius at 1 atmosphere siya. At STP, something like that, okay? Remember that one? An ideal gas will occupy 24.414 liter, okay, of an ideal gas, of 1 mole of an ideal gas, something like that at STP. Sorry po ah. Okay, that's the first, second, and third law of thermodynamics. Okay, then in this topic also of thermodynamics, we need to understand the terms, the enthalpy. Okay, so enthalpy talking about there must be a change in energy. Okay, and then we have the, of course, the entropy because that's our topic, and then we have the Gibbs free energy, delta G. Okay, the delta G, or Gibbs free energy, will tell us how spontaneous a process really is. Okay, so here in this topic of thermodynamics focuses more on the how spontaneous, non-spontaneous the process really is. Okay, something like that. Okay, now three terms: gives free energy, delta G, enthalpy, delta H, and the entropy, okay, delta S. That's entropy, right? S, represented as S. Okay, but the gives free energy is equal to the enthalpy, change in enthalpy, H minus temperature times the delta change in entropy. So in this formula that gives free energy, we can determine how spontaneous, non-spontaneous the process is. Okay, like that. Okay, so that's very clear for the introduction of thermodynamics. So for example, uh, our entropy will be like this. Okay, how much is your gives free energy, and then through that, if for example, if positive, ganun, that is non-spontaneous. If negative, delta G, that is spontaneous. Okay, like the negative gives free energy, negative delta G is really a spontaneous if negative, if positive, non-spontaneous. Okay, it's in here also that we need to focus on the favorability, delta H. Delta H, since this is the, the energy transfer, something like that. So this is more on the energetically favorable, something like that, at negative sign in delta H. Okay, and then for our entropy, that is entropically favorable at positive sign, and the resulting delta G gives free energy will be the spontaneous. Okay, like that, which is the negative. Okay, the negative is the spontaneous, negative delta G, or negative gives free energy. So ganitong gives free energy tells us how spontaneous the process really is. Okay, the spontaneity of the process, something like that. Okay, so a lot to remember for this, huh? The energetically favorable, energetically unfavorable, entropically favorable, entropically favorable, something like that. Okay, and then the unit will be joules per Kelvin, something like that. For the entropy, joules per Kelvin. Okay, like that. And then if you want to get the energy in terms of joules, then multiply that with a change of temperature, so that it could agree to the enthalpy. Then we can now obtain the gives free energy. Energy is joules man siya talaga. Okay, it's related also to physics, right? Energy. So thank you so much, guys, for watching this very short vlog of mine, basic introduction of thermodynamics. Thank you so much, guys. If you are not subscribing at my channel, then you can subscribe now and click some notifications bell of I am a singer, eternal voice. My gosh, really? Okay, so this is the first discussion regarding thermodynamics. Bye bye again, bless everybody.